The latest from CERN, Brian Cox discusses the unexpected discoveries. Have you ever wondered where the boundaries of human knowledge truly lie? At the heart of Europe, buried deep beneath the Swiss-French border, lies CERN, a place that not only pushes these boundaries but often obliterates them entirely. Home to the world's most advanced particle physics experiments, CERN has already reshaped the way we understand our universe. Today, we journey into this world of high-energy collisions, guided by the ever-fascinating physicist Brian Cox, to explore a story of discovery, risks, and unanswered questions. CERN's Large Hadron Collider, LHC, is renowned for its discovery of the Higgs boson, often called the God particle. It was a scientific triumph, confirming predictions that had remained unproven for decades and cementing the Standard Model as a cornerstone of physics. But progress, as it often does, refuses to stop there. The LHC is now delivering data that throws perplexing shadows on the seemingly solid foundation of the Standard Model. The question is, are these anomalies random noise or keys to unlocking a new frontier of physics, and by extension, life itself? Brian Cox, with his unique blend of expertise and narrative brilliance, invites us into the very heart of this enigma, asking us to imagine what it means to challenge fundamental truths. Are the recent discoveries a sign of the unknown marvels awaiting us, or could they lead us into unforeseen chaos? To understand why these unexpected discoveries are so significant, we need to revisit why CERN exists in the first place. This isn't just any scientific institution, it's the pinnacle of collaborative human effort to explore the fundamental forces of nature. The Large Hadron Collider, with its 27-kilometer ring of superconducting magnets, smashes particles together at mind-boggling speeds, recreating the conditions that existed fractions of a second after the Big Bang. CERN's crowning achievement so far has been the confirmation of the Higgs boson in 2012. This elusive particle, critical to explaining why objects have mass, was the last missing piece of the Standard Model of particle physics, a framework that has explained nearly every observed aspect of the universe with astonishing accuracy. For years, physicists believed that the Standard Model would remain unshaken, the ultimate guiding script of reality. But science doesn't rest on laurels. The real-world data pouring out of the LHC is baffling researchers. Tiny deviations, subtle anomalies, are emerging, ones that do not fit neatly into the existing framework. So, what exactly is happening at CERN? Recent experiments have observed behaviors in particles that deviate from what is predicted. LHCb, one of the experiments dedicated to studying the differences between matter and antimatter, has returned results that raise eyebrows. Particles like B mesons, small and fleeting, are decaying in patterns that physics doesn't fully explain. Even more intriguing is the peculiar behavior of muons, heavier cousins of the electron. In theory, their interactions should align perfectly with the predictions of the Standard Model. Yet, in practice, they don't. They suggest forces or particles we've never encountered before, rippling hints that provoke both excitement and caution across the scientific community. Are we facing cracks in what was once seen as an unbreakable wall of understanding? For decades, scientists have been searching for evidence of new physics, something that builds on or even replaces the Standard Model. But these findings are like whispers in the dark, faint, cryptic, and full of potential. What's at stake here? Everything. If these anomalies are proven to be genuine and not just statistical flukes, they could open the door to a new era in physics. The Standard Model does an extraordinary job of explaining what we know, but it fails when asking the bigger questions. Why does gravity behave differently from other forces? What is dark matter, the mysterious substance that accounts for most of the universe's mass? And what role does dark energy play in driving the expansion of the cosmos? If there are new particles or forces waiting to be discovered, they could help us integrate quantum mechanics, the science of the ultra-small, with Einstein's theory of relativity, which governs the cosmic scale. This theory of everything has eluded physicists for generations. Could these startling results at CERN be the first real step toward it? However, Brian Cox doesn't shy away from acknowledging the risks. Stepping into the unknown is as perilous as it is thrilling. It isn't merely about charting a new map for physics, it's about the implications such discoveries bring for technology, philosophy, and even how we perceive the role of humankind in the universe. Imagine standing on the edge of a cliff, staring into an endless abyss. That's what some of these unexpected discoveries feel like to scientists. The anomalies at CERN aren't just intellectual puzzles, they are challenges that demand re-evaluation of long-held beliefs. But when you push past the boundaries of known science, there's a risk of misinterpreting data, overhyping results, or neglecting subtle complexities. Brian Cox reminds us of the balance that must be struck in high-stakes science. On one hand, we need the courage to explore. On the other, we need the humility to admit what we don't yet understand. The mistakes made when attempting to leap too far, too fast, could jeopardize not only the reputations of scientists but also the public trust in scientific endeavors. And there's another question. What if we unlock phenomena we cannot fully control? History is littered with inventions and discoveries, nuclear energy, artificial intelligence, that brought as many questions as solutions. Are we prepared for whatever lies beyond the data anomalies at CERN? What does all of this say about us as a civilization? Humans, by nature, are seekers of truth. Science is our tool for unraveling the mysteries of existence, but discoveries like these challenge our philosophical foundations. Why does the universe behave as it does? And perhaps more hauntingly, does it behave the same way everywhere and at all times? These questions aren't just for scientists and labs. They invite deeper reflection about humanity's desire to know the unknown. Brian Cox poses a profound idea. In challenging the standard model, are we nearing the ultimate truths of reality, or are we simply peeling back a layer to reveal an even grander mystery? Such breakthroughs could redefine everything, from our understanding of space and time to the ethical considerations of manipulating newly discovered forces or particles. It's a humbling reminder of our place in the cosmos, a tiny speck, yet capable of wielding astonishing power in understanding it. If history is any indication, scientific discoveries lead to unexpected technological revolutions. Electricity, lasers, the internet, all of these sprang from abstract scientific exploration. If anomalies at CERN indicate new forces or particles, the ripple effects could touch every corner of human existence. Imagine harnessing materials or forces previously thought impossible, revolutionizing energy production, transportation, or medical technologies. But again, with enormous potential comes enormous risk. The question lingers, are we ready for such a leap? By looking deeper into CERN's operations, we see the immense complexity and collaboration that underpins these discoveries. The equipment, from superconducting magnets to particle detectors, operates at temperatures colder than outer space. Teams of scientists, engineers, and researchers from all over the planet contribute to this effort, their shared goal being the pursuit of knowledge for the benefit of all humanity. Yet, this high-level collaboration carries its challenges. The anomalies found are scrutinized under the harshest light, debated, tested, and retested to ensure their validity. Brian Cox gives us a rare glimpse into this dynamic world, where every piece of data has the potential to rewrite textbooks. CERN's latest discoveries are more than just flashes in the scientific pan, they are a profound invitation to rethink the very fabric of our universe. Brian Cox invites us to look at these findings not as mere scientific curiosities but as provocations for the human spirit. The stakes are high, wild possibilities, revolutionary technologies, and perhaps even an unsettling confrontation with the limits of our understanding. Will these revelations lead humanity to a renaissance of discovery, or will they prove to be Pandora's box, unleashing questions we're unprepared to answer? That remains unknown. But one thing is certain, the search for meaning at CERN is not just about physics, it is about who we are as a species and what risks we're willing to take in our relentless quest for knowledge. So, as the Large Hadron Collider continues to smash particles at unimaginable speeds, it's not just the building blocks of the universe that are being tested. It's us. Our resolve, our curiosity, and our readiness to face whatever truths lie waiting beyond the horizon. Let's keep watching, questioning, and wondering. After all, this is what it means to be human.